με την πρώτη ομιλία που προσκαλέσανε η Οργανωτική Επιτροπή σχετικά με την βιογεοχημία. Μάλλον στα αγγλικά θα το πείτε. Of the Anaximenes Seamount. Molecular evidence for a seamount effect in particulate organic matter quality. Πολύ ενδιαφέρον και από πλευράς χημείας και βιολογίας και γεωλογίας, πιστεύω.
Ευχαριστώ.
Καταρχήν,
ευχαριστώ για την πρόσκληση και παρακαλώ να με προσκαλείτε πιο συχνά, γιατί στην Αγγλία βρέχει και κάνει κρύο. Όταν έφυγα χθες είχε 2 βαθμούς. Λοιπόν, ευχαριστώ πάρα πολύ. Θα σας πω κάποια πράγματα, δυστυχώς στα αγγλικά, για τα Seamounts και για κάποιες εργασίες οι οποίες κάνω τα τελευταία χρόνια. Είμαι στο Πανεπιστήμιο του στο John Moores, Πανεπιστήμιο του Λίβερπουλ, το οποίο ήταν το παλιό Πολυτεχνείο, αλλά συνεργάζομαι πολύ στενά με άτομα από το Πανεπιστήμιο του Λίβερπουλ για αυτή την εργασία και για άλλες. Λοιπόν, Seamounts. Seamounts, you probably know that are underwater mountains that are above 1,000 meters, and we don't really know how many they are in the global ocean. This was a recent paper, an estimate from these people, and they've estimated it's around about 33,000 seamounts, and if you include the knolls, which are a little bit less than 1,000 meters, like abyssal hills, for example, these are 138,000 according to these people. The numbers next to them are the percentage of the seafloor that they occupy. And if you make the calculations, it turns out that seamounts occupy the size of Russia, and the knolls, if you include the knolls, that would occupy the size of Asia, or a little bit more than that. So they occupy a really big area of the world's oceans. So that's one very good reason for researching these ecosystems in these areas, because there's so many, and we don't really know what to do. In fact, there are some theories, and people have been working on seamounts for a number of years now, and have observed a few things, and they have some ideas about them. First of all, I have to say that so far, out of the 33,000, we have, there is data for about a bit less than 300 of them, so a very tiny, less than 1%, a very tiny proportion of them has been studied in any way. And one thing that is well known is that there are supposed to be hotspots for marine life and diversity. Very often people observe large benthic and pelagic biomass around seamounts. That means a lot of fish, a lot of zooplankton, a lot of sessile organisms like cold water corals, for example, and other species. And that has sparkled the interest, perhaps, from a biological and biogeochemical perspective. Why do you find these high abundances of marine life in these areas? A couple of theories associated with seamounts. One of them is, as it's called, the island theory, and it's called like that because it was thought initially that they also have high levels of endemism. In other words, endemic species that you find nowhere else. At the moment, as things stand, I think this idea is being disproven. The more research we do in seamounts, the more people realize that there's not such a big level of endemism. But hey, it's only 1% we've studied so far, so it's still an open question. The other idea is the fact that these seamounts are supposed to be productive areas. So this is called the oasis theory. In fact, that they function as an oasis in an otherwise rather oligotrophic ocean. Now, the evidence for that is still an open question. It's a little bit sporadic, and I think I'm going to concentrate on the rest of my talk trying to talk about this theory, whether you do find an evidence for high abundances, high biomass, what the reason may be, or how that affects other processes in the ocean, such as elemental cycling, for example. Now, the interesting thing about seamounts is that, of course, they interact in a very complex way with the physics, with the hydrography of the ocean. Very often, people have postulated that they cause upwelling, and upwelling, of course, brings nutrients from below and may cause high primary productivity, and then everything else follows after that. You have high levels of zooplankton, fishes, whatever, Of course, for that, most people agree that the seamounts have to be relatively shallow, in other words, very close to the surface to have a noticeable effect, but that's not necessarily the truth. So upwelling, induced upwelling, and subsequent primary production is one of the theories that comes out of this complex interaction with the physics. The other is that they also create these strange structures around them, like an eddy above the summit of the seamount, which have a name, and they're called Taylor column, from the physicists that study them or created the theory in the 50s, I think, or the 40s, I don't remember. A good paper for that is by White et al. 2007. And this has it has the effect that it may concentrate or retain the particles around the seamount. It almost seals the seamount, or the area above the seamount, the water, from the rest of the ocean. What effect this may have, whenever it's possible to happen, to the biology and the biogeochemistry of the system, it's a different story. Whether it traps good particles, lots of particles, or traps an area with no particles, that's a different story. Another idea that is related to this theory is actually the fact that they may act as a hindrance to zooplankton migration, this vertical dial zooplankton migration, which is usually, I don't know, 800 meters or so. So if it's around the seamount, zooplankton tends to concentrate in the depth, and maybe that helps fishes and other predators to actually gorge on this zooplankton. Of course, these are theories, and there are other theories as well that have to do with spawning and all that stuff. But one theory that I'm particularly interested in, and I don't think it has been mentioned very often, I think because it's fairly new, is because there's so many, because they have so complex interaction with the physics, but also the biology, they may probably affect elemental cycles, as I said, particularly the carbon cycle. This is some data that I happened to come across just a few days ago, almost by accident, from a PhD thesis. It hasn't been published in a journal yet, hopefully it will. And this is from a cruise that crossed the Atlantic in 2007 at 36 degrees north. You can see the cruise track in the top diagram. And the bottom diagram, you see the concentrations of dissolved organic carbon. And as you notice, every time the transect goes crossing an elevation, a topographic elevation, whether that was a seamount or the mid-ocean ridge for that matter, the mid-Atlantic ridge, this is at the middle, you could see this plume, this downwards plume of dissolved organic carbon. Now, as I said, I've just seen this data, and I thought it was extremely interesting to put it in, and we'll try to publish it, but how it's created and how it's maintained, whether it is maintained at all, it's a different story. We'll have to investigate a little bit more, but it's nevertheless very, very interesting, because if that's true and it happens commonly, then that means that these topographic elevations, and in that I include the mid-ocean ridges, could actually have a significant effect of the downwell, or the transport of carbon from the surface to the interior of the ocean. So along these lines, let's summarize the sort of questions you may have about the seamounts. I like to use this question about the seamount effect. Is there a seamount effect in the ocean? What that means? That do you have enhanced local primary productivity or secondary productivity, which may follow this zooplankton, or a trapping of affected particles? What about temporal variability? This is a big issue, actually. Even primary productivity can be seasonal. So you may go in one cruise and observe nothing, next cruise may observe lots of things. And that has been the biggest problem, actually, with seamount research, the fact that they're so far and so difficult to sample. And when you're there, it's critically important to understand and observe these processes. The same goes for Taylor columns. I think most physical oceanographers will tell you that they are transient features, which means once they're there, once they're not, and it's pretty much down to luck, as far as we know at the moment, whether you're going to see them. Probably seasonally affected as well, but all these ideas are almost at the beginning at the moment, and people are still trying to figure out what is the best way of sampling these areas. The last one, it's something that I'm particularly interested in, and I think we've promoted in our group in Liverpool, and that is we try to focus not only on how much material is concentrated around seamount, whether that's living material or dead material, but what is actually it, what is its status of the material, particularly particular organic material, because this is the food of everything that, that may congregate around seamounts. So what I say, when I say what is the state of it, I particularly mean the quality of it in a nutritional status. Is it a good quality stuff, or is it degraded stuff, for example? It's not easy to identify quality or observe it, but you can use one way by looking into molecular studies, and particularly to this, in these compounds, these chemical compounds that are called lipid biomarkers. Now, lipids, you probably know them, are the fats we have in our body. They're in every organism in the planet. Some of them have a known biological origin, and that's why they're called biomarkers or biological markers. And I chose to give an example of two common ones, which you probably know because you must have seen them in the health shops in the supermarkets. These are the typical omega-3s, the fish oils that people know them. In fact, they're biosynthesized by phytoplankton. DHA, the one at the top, is biosynthesized mostly by dinoflagellates, eicosapentaenoic acid. EPA at the bottom is biosynthesized by diatoms. The thing about these compounds is that they're very energy rich and very labile. I think some people have done some experiments. They found out they disappear within less than a week. So the idea we've had is to use these compounds as markers of organic matter quality. In other words, if you have them in high amounts, you got good quality organic matter. If you don't have it in high amounts, your organic matter around the seamounts may be degraded. There are a number of other biomarkers which I will mention later in the talk, but these are quite important. So we have something to actually give us a little bit of support in this theory about the importance of organic matter quality in this type of work. This is some work that was done a few years ago in a seamount in the North Atlantic. It's called the Seine Seamount, and it's not far from, a little bit north of Madeira. And this was some data from zooplankton biomass that was taken in spring 2003. And as you can see, I said to you before that very often you find high levels of zooplankton around seamounts. This actually shows exactly the opposite, that on top of the seamount you have low amounts of zooplankton. And in fact, the far-field site, the control site, if you want, had higher amounts of zooplankton. Now that's interesting in itself, and it's not the only time has been observed, and there are, again, quite a number of theories would probably relate to the timing of the sampling. But the interesting thing is that when I did, that was published by Martin and Christiansen in 2009, and this is published by me in 2009 again. When I looked at the particular organic carbon concentration, in the same transect that they did the zooplankton netting, I didn't particularly find any correlation. You had quite low concentrations away from the seamount and relatively higher concentrations around the seamount, although it's not, you cannot say really much because there were only 4 samples. However, when I looked at the polyunsaturated fatty acids, these omega-3s I was telling you just before, the fit was perfect. Where you had no polyunsaturated fatty acids, you had very little zooplankton. When you had higher polyunsaturated fatty acids, you had high zooplankton. And we think this is an important issue. In fact, there were some papers in Nature a few years ago that they actually linked these particular compounds to the carbon transfer efficiency in food web systems. So we think there's something that could be investigated over there. Not only over there, but around seamounts. So we went to the Anaximenes a few years ago in 2006 in a German cruise with a meteor, and we did all sorts of things. One of the reasons that we chose Anaximenes is that it was, of course, within a very oligotrophic, ultra-oligotrophic sea, as most people call it, and it also has warm waters all the way to the bottom, about 30 degrees all the way to the bottom. So we wanted to see if there is any discernible effect that the seamounts may have on this area, and we chose to look at Anaximenes. You see the sampling sites there with the red dots, and also we looked at one sample from the Rhodes Basin further away. So what I did for my work, I sampled lots of particles, suspended particles, because of the sort of complex interaction of topography and the physics, sediment traps do not work terribly well there. We use these devices which are in situ pumps, and they pump up to 2,000 liters of water. So you have a rather representative chunk of water to work with, and also you've got quite a bit of sample as well to work with. So the sampling scheme goes like that. We used one of these pumps at 50 meters, then, in other words, within the euphotic layer, a little bit below the euphotic layer, 150 meters, and also close to the bottom at 3 sites, a control site on the summit of the Seamount and the trough of the Seamount. It's a complex area, this Seamount, I forgot to say. It's Anaximenes, Anaxagoras, and Anaximander. And there's a trough between the Anaximenes and Anaxagoras. So we chose to sample the trough. The biologists also did the zooplankton netting as well, more or less in the same areas. So what I found, these are results that I'm looking at the moment. It hasn't been published, but will be published in the next few months. So this is the particular organic carbon and the particular nitrogen. And what you see is, if you concentrate on the carbon on the left, you see that it's very variable in the seamounts and the trough, in the seamount and the trough, but the lowest value, the yellow triangle, the yellow diamond, is the far away side, which is interesting, but it's only one sample. Another peculiar thing that I've never found myself anywhere, I've been doing these things for about 15 years now, and I've never seen increase of particular nitrogen with depth, and this is what you find in the right diagram. It's quite interesting, but I think that's probably, I'm not sure how to interpret this, but I'm probably relates to this peculiar situation of that particular part of the ocean, which is phosphorus limited, and it has quite a lot of atmospheric deposition of nitrogen that may hang around in the waters and give this high, or rather very low, C/N ratios. As I said, it's something I've never seen before, and I'm still trying to get my head around it. Any ideas, welcome. Then I looked at the lipids. The lipids, and you see there the total lipids and also the total fatty acids and the total polyunsaturated fatty acids. I have to say that 90% of the lipids were fatty acids. And you see more or less the same thing as you saw with a particular carbon before. High variability at the surface, close to the surface, the lowest values at the control site. The interesting thing is that they all disappear, like exponentially. This is the typical textbook profile of organic carbon and organic material in the ocean. And particularly the PAFAs, the polyunsaturated fatty acids, they almost disappear almost entirely. No really seamount effect, a discernible seamount effect, or no sort of robust seamount effect, if you want to call it like that. However, when I looked at other classes of lipids, in particular the alcohols, the sterols, and the bacterial lipids, then things were very, very different. And particularly the alcohols and the sterols saw increases with depth rather than decrease. So then that's quite unusual. And what we think is happening is that you have these compounds are markers of zooplankton modification. They're rich in phycopellets. Therefore, that's what you're sampling there. You're sampling a different type of organic matter, which is more processed, more reworked, if you want. Therefore, not as good quality as you would see at the surface. Okay, this is all very good, but is it really a seamount effect? Well, we did a statistical analysis using Primer, the software, and what you can see there is a multi-dimensional plot of the 50 most abundant biomarkers. So each dot you see there has 50 variables in it, and this statistical program sort of checks for differences. And what you see is that two groups, they cluster in two very, very separated groups. And the green ones are all the surface samples. The colorful ones are all the deep samples. And as I said to you before, that's driven by the disappearance of polyunsaturated fatty acids and the increase of these alcohols and the sterols. So again, you probably see a depth effect. But the interesting thing is, I don't know if you can see it very clearly, the only one sample, surface sample that is clustered with the deep sample is actually that one over there. Don't know if you can see it very clearly. but that's taken from the control site. So the control site shows not only a low organic material, but material that's also very degraded, as if it was material that comes from the bottom or that has been reworked extensively. So my question is that a Seamount effect? Okay, one sample, based on 50 variables, but still one sample. You can't really say much with one sample, and that's intrinsically the big problem of this research. Looking at it retrospectively, I think we should have done more sampling in the Rhodes Basin. And I have to say here that the other people that were on the cruise, the biologists, when they looked at the zooplankton data, they did not find any Seamount effect, and they suggested that what they did find was actually controlled by the general circulation of the area, this cyclonic gyres. There's the Rhodes gyre, which may be causing upwelling, or the Anaximander eddy, that it's sometimes there next to the Anaximander, not exactly on top of it, that may cause the difference in zooplankton. In fact, they found more zooplankton in the Rhodes Basin than less than in the Anaximenes. Again, with one sample, you can't really say much. Maybe I was unlucky or lucky to sample a very degraded patch of water when I was in the Rhodes Basin, or maybe because what was left over from all that zooplankton that they found that it was abundant there. We don't know. So where do we stand now with this data? This is some of the data that I'm working on. We have other data from other seamounts as well, but it's more or less the same story. So I have to say at this moment, the jury is still out. We don't know whether there is a continuous, at least, seamount effect in the ocean or not. That this is probably, in my view, more of a sampling limitation and approach limitation more than anything else. So I'd like to do, again, but better next time. Thanks for listening, and many thanks to the crew masters of Meteor and Sensim, Sensors of Seamount, for funding this research. Thanks very much.
Ευχαριστούμε πολύ τον κύριο Κυριακουλάκη για την ειλικρινά εξαιρετικά ενδιαφέρουσα παρουσίαση. Θέλω να ρωτήσω αν υπάρχουν ερωτήσεις από τους ακροατές.
Ναι. Yes. Yeah. Yeah. Chlorophyll would be good. If oxygen would be also very good. Don't know if there is any way to sample particles, but if we have any chemical sensor we can put on the glider, that would be excellent. And go back and forth and transect between seamounts and control areas all the time, that would be excellent, because that's what's really needed. A continuous monitoring of these systems. I don't think we can see it with spot sampling like in a cruise or something.
You can say that we have optical sensors for chlorophyll and backscatter.
Yeah,
but it's uncalibrated. We haven't gone and taken samples.
Right.
Calibrated counts.
Yeah. Look, thanks for that. That's very interesting. That's what should, the next step maybe. Thanks.
Άλλη ερώτηση, ο κύριος Φραγκούλης.
So maybe using dependent method you use, you can have an overestimate of the years of plankton.
Yes, I didn't mention that in the cruise, but they also looked at dead carcasses, for example, and they didn't find any higher amounts of carcasses either. So they looked both at the dead zooplankton and the live zooplankton. However, in other cruises, in other expeditions, they have found little live zooplankton but high amounts of dead zooplankton as well. So the problem is that every cruise you go, you see different things, more or less.
Άλλη ερώτηση. Εγώ θα είχα μια ερώτηση. Ο κύριος Λυκούσης, συγγνώμη.
Θέλω να σε ρωτήσω, εγώ που ξέρεις βιολόγο,
Ναι.
συνδέθηκα με κάποιες ερώτησεις συγκεκριμένες. Επειδή έχουμε δουλέψει στην περιοχή, δύο στοιχεία που πιθανόν να παίζουν κάποιο ρόλο, πιθανόν να παίζουν κανένα. Έχετε, οι δύο δειγματοληψίες ήταν κοντά σε
Θα ήθελα... Ευχαριστώ. Θα ήθελα να τη δω αυτή τη δημοσίευση. Όσο για τα άλλα, ναι, κάναμε δειγματοληψίες στο, νομίζω είναι το Θεσσαλονίκη mud volcano, στο οποίο έχω είχα ένα πυρήνα αποζήματα. Και η τρόφ, όπως είπα, αυτή η κοιλάδα που ήταν μεταξύ των δύο Seamounts, ήταν εκεί που ήταν το Θεσσαλονίκη mud volcano. Αυτά θα τα κοιτάξω ξανά όλα αυτά τα δεδομένα με λίγο πιο περισσότερο χρόνο τώρα και θα κοιτάξω λίγο πιο περισσότερο τι μπορεί να βγει από όλα αυτά. Όχι, δυστυχώς. Αυτό ήταν.
Άλλη ερώτηση. Αν μπορώ να σας κάνω. Επειδή έλειψα από την αίθουσα, δεν ξέρω αν παρουσιάσατε κάτι σχετικά με τους άλλες συνιστώσεις της τροφικού πλέγματος, δηλαδή φυτοπλανκτών, μικροζωοπλανκτών, βακτήρια.
Όχι, εγώ δεν το έκανα αυτό. Νομίζω οι δύο συνάδελφοι, Denda Christiansen, έχουν κάτι λένε στην δημοσίευσή τους, η οποία δημοσιεύθηκε το 2011, σχετικά πρόσφατη. Εστιάστηκαν στο ζωοπλανκτόν, αλλά κάναν και δειγματοληψία του σωματιδιακού. Αλλά όσον αφορά το φυτοπλανκτόν, θα κοιτάξω τώρα δεν υπάρχουν πολλοί ακόμα που έχουν κάνει πολλές δημοσιεύσεις από αυτή την αποστολή. Θα κοιτάξω ποιος ήταν και νομίζω ήταν άτομα τα οποία κοιτάξαν το φυτοπλανκτόν. Δεν νομίζω να τα έχουν δημοσιεύσει ακόμα. Μπορώ να τους ρωτήσω.
Εγώ πάντως προσωπικά εξεπλάγει με το γεγονός ότι διαλέξατε την περιοχή της Ρόδου σαν περιοχή αναφοράς, τη στιγμή που υπάρχουν αρκετές εργασίες, δημοσιεύσεις ή και ανακοινώσεις που δείχνουν ότι είναι μια περιοχή αυξημένης παραγωγικότητας. Δηλαδή, δεν θα τη θεωρούσαμε στην Ανατολική Μεσόγειο σαν περιοχή αναφοράς.
Ίσως, αλλά να σου πω την αλήθεια, δεν ήμουν και τις αποφάσεις τις πήρα ο αρχηγός της αποστολής. Αλλά τώρα, βλέποντας και κοιτώντας περισσότερο τα δεδομένα, θα ήθελα να κάνω αν γινόταν να το ξανακάνω, μια transect. Είτε από τη Ρόδο ή κάθετα από την Αντάλια προς τα νότια, αν γίνεται. Νομίζω αυτό είναι πολύ καλύτερο. Και φυσικά να κάνω πολύ περισσότερες δειγματοληψίες εκτός του Seamount, σε περιοχές αναφοράς, όχι μόνο στο Seamount. Γι' αυτό ήταν το μεγάλο πρόβλημα που έχουμε, είναι ότι δεν έχουμε πολύ καιρό. Αυτή ήταν ήταν 12 μέρες μόνο η αποστολή και δεν είχαμε 25 άτομα, όλοι κάναν διαφορετικά πράγματα, δεν είχαμε πολύ καιρό για να κάνουμε πάρα πολλούς σταθμούς, δυστυχώς.
Όμως έτσι μένουν πράγματα για να διαρρευνήσουμε παραπέρα.
Ναι, ακριβώς. Είναι γαργαλιστικά, θα έλεγα. Τέλος πάντων.
Ναι. Ευχαριστούμε και πάλι.
Ναι.
Να περάσουμε στην επόμενη παρουσίαση, που είναι από την κυρία Ανδρονή, και είναι μια εργασία της κυρίας Ανδρονή, σε συνεργασία με την κυρία Κρασακοπούλου, την κυρία Παυλίδου, την κυρία Σουβερμέζογλου, τον κύριο Σκούλο και τον κύριο Δασενάκη, και αφορά το διαλυτό οργανικό άζωτο και το φόσφορο, τις μετρήσεις των συγκεντρώσεών τους και τη δυναμική τους σε διαφορετικές περιοχές της Ανατολικής Μεσογείου.
Ευχαριστώ. Λοιπόν, αυτό είναι το θέμα της εργασίας μας. Πρέπει να σημειώσω ότι έγινε στα πλαίσια του προγράμματος Σέσαμι και πραγματοποιήθηκε την Άνοιξη και το καλοκαίρι του 2008. Η διαλυτή οργανική ύλη αποτελείται από το διαλυτό οργανικό άζωτο, διαλυτό οργανικό φόσφορο και το διαλυτό οργανικό άνθρακα. Όλα αυτά, μαζί με άλλες βιοχημικές παραμέτρους, μας επιτρέπουν την εκτίμηση και το χαρακτηρισμό της τροφικής κατάστασης μιας θαλάσσιας περιοχής. Η διαλυτή οργανική ύλη παράγεται και αποσυντίθεται από τους μικροοργανισμούς στους ωκεανούς και συνεισφέρει στη μεταφορά της παραγωγής στις